One of the features of the 429 is its ability to conduct one engine inoperative training operations. Just like in a single engine aircraft, instructors and pilots will go out and practice engine failures and touchdown auto rotations. In a twin engine aircraft, we have the ability to conduct engine failure training as well. And in a modern aircraft like the 429, we have a training switch called the OEI training switch, One Engine Inoperative training switch. And that allows the computer to simulate an engine failure without the engine actually rolling back. So we don't have to manipulate any throttles, as it reduces the risk in the training environment. But it also gives the flying pilot the actual indications of an engine failure, and it allows the engine control unit to limit the rotor or limit the power of the operating engine so that we can actually induce rotor droop, as would be the case in a real engine failure. This is all part of the aircraft certification, as even though the aircraft certified under Part 27 for normal category aircraft, the 429 is also certified to some portions of Part 29 when it comes to engine isolation. And those certifications fall under the Category A standards. So we call these, Category A flight maneuvers or Category A training. And but basically, we're training to account for an engine failure. When we do a Category A maneuver, we have a point in the takeoff profile called the takeoff decision point, or TDP. And that point is calculated based on aircraft weight and density altitude and the type of takeoff.
Runway 35, clear for the option, wind 30012.
And the type of takeoff that we're doing. And so for the 429, there's two separate takeoff profiles that it's certified to do under Category A standards. One of them being the helipad takeoff. And the design intent here is that at any time in the takeoff profile, the aircraft can either safely abort the takeoff and return to the takeoff point, or it can continue the takeoff profile and fly away safely without hitting any obstacles. So basically we can survive an engine failure at any point in the takeoff profile. So what we're going to demonstrate today is both of those scenarios. We're on the helipad, and we are going to simulate an engine failure using the OEI training switch to have an engine failure prior to our takeoff decision point. And for training today, we're going to use about 75 feet for our takeoff decision point. And we're also going to discuss the helipad departure profile. It's quite steep, and you might have heard people ask sometimes, well, why do EMS helicopters always take off backwards? Well, one of the reasons is because they are performing a Category A takeoff profile. And our intent is to be able to maintain sight of the helipad during the takeoff profile. In the event of an engine failure, I can easily return to my point of takeoff. And in the 429, the sight picture ends up being right outside the pilot's window above the door handle. So depending on which pilot is flying, the left or the right seat, that's the sight picture we're trying to maintain. And so we're going to take off near vertical with some backwards movement in order to maintain that sight picture. In this scenario, we're going to have an engine failure prior to TDP. And what that'll look like is the engine will simulate a failure. We'll get some indications on the primary flight display of an engine failure. And the reaction from the pilot is to just abort the takeoff and return to the pad. Depending on aircraft gross weight, the rotor may droop a little bit. Our goal is to maintain about 100% RPM. For all Category A operations, we do the operation at 104% rotor, and that allows us to droop it to 100, and that ensures that we're getting the maximum performance out of that engine. All right, so we're going to demonstrate that. We have before takeoff checks are complete, throttles are in flight, RPM is 104, and this will be a demonstration of an engine failure prior to TDP. All right, so we're going to come up to a hover. Okay, flight controls feel good, all the gauges feel good. And again, we're using about 75-foot TDP as our training takeoff decision point.
865, we'll got you in sight, we'll pass.
So I would start a climb with a slight aft movement. I'm keeping my sight picture of my helipad in my windscreen. And then we would simulate an engine failure there. So there's a number 1 engine failure. I'm prior to TDP, so I would be aborting, and I'd be returning to the helipad safely without any damage to the aircraft, or without it exceeding any limitations on the operating engine. And back down to the ground we go. We land in safely. Collective goes all the way down, and that's termination of the maneuver. During that operation, we heard a couple chimes that indicated that that operating engine was operating in a time-limited operation. When we go one engine inoperative, our limits change on the operating engine, and we have a 2-minute time-limited operation zone. We have in a 30-second time-limited operation zone. If the engine were to go to the top of the 30-second time-limited operation zone, then the engine control unit would actually limit the power and we would start to droop the rotor. Okay, so we're going to return the OEI training switch to center, and it'll give us both our engines back. The next demonstration is going to be a simulated engine failure after the takeoff decision point. And so we're going to continue to take off. We're going to climb. We're going to reach 75 feet, which will be our TDP, and we'll start our takeoff profile. The goal here is to complete the takeoff safely and account for an engine failure. So after the engine fails, our goal is to get some airspeed, and we're looking for a takeoff safety speed of 50 knots, and our intent is to droop the rotor to about 100% to get that climb profile going. And we're going to do that up until about 200 feet AGL, at which time we have finished the stage 1 climb segment, and we'll aim for a climb speed of about 60 knots and the rotor back to 100%. So this will be a continued takeoff with an engine failure after TDP. Let me call the tower for clearance. Tower stage 49 is west helipad, so left traffic back to west helipad.
Stage 49er, landing departing west helipad, beach on risk, left coast traffic approved, wind 30010, clear for the option.
Stage 49. Okay, so again, coming up to hover. Flight controls feel good, hover power check, and everything's operating in the green. And we'll begin our takeoff profile. So here we're coming up, we're still maintaining our sight picture.
Stage 14 up on this frequency. Say again?
Okay, approaching TDP. There's TDP, we're flying, we have a simulated engine failure. And our goal is to get the airspeed alive. There's the rotor. There's the airspeed, we're looking for 50 knots. There's VTOS, a positive rate, rotor's at 100%. And we're holding that until about 200 feet. We get the rotor out of the 30-second time limit operation, and we hold VY, and RPM switch comes back to 100. And that completes the continued takeoff with an engine failure after TDP.